Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and sitting in this week for Gary Kildall is Herb Lechner of SRI. Herb, what we have up on our Apple computer here today is the Koala Micro Illustrator and my handy Koala pad here. And we see a menu of some artists' choices, and if I can, I'm going to try to communicate to you here in some computer graphics. And so far, it's working. If I get your name right. There we go, and I can even make it a little more sexy than that. We'll give you a little brighter background color so it's a kind of more upbeat message. Herb, computer graphics is the subject of our show today, and computer graphics, in fact, involves more than just this little thing we're playing with or even video games, which some people associate with computer graphics. There are some pretty serious applications, aren't there?
Very much so, Stuart. Computer fine art hangs in galleries right alongside of traditional art. And, of course, in the commercial area, computers aid animators and play a very important role in TV advertising today. And, of course, the basic building blocks of computer art, that is, the graphics subsystems, play a role not only in art, but in related activities such as computer-aided design and other graphic applications.
Okay, on today's program, we'll be looking at one of the newest computer graphic systems called Iris. We'll look at a computer art system called the Paint Box, and we'll meet two computer artists, real people, that is. First, let's take a look at the kind of computer art being done now on mainframe computers. Since the first light pen and graphics displays of the 1950s, computer-assisted artwork has been associated with beautiful, if mathematical, images of symmetry and abstraction. But the applications today extend far beyond repetitive patterns. With enough computing power, computer graphics can extend an artist's reach to cover the height and length of a wall, or compress the time it takes to animate something from a month to an hour. Using a digitizing tablet, MIT artist Ron McNeil chooses from a palette of colors and pre-programmed images to create a collage that exists only in the computer's memory. Before ever seeing a canvas, it undergoes some dramatic transformations. Starting with materials from different sources like photographs or three-dimensional objects, the composite can be manipulated to change in color, size, or geometric aspect. The screen-sized image shown here is only an intermediate step toward the final hard copy, a painting that is 14 feet high and 48 feet long. Like a colossal paintbrush with a memory, the giant XY plotter magnifies the completed artwork into a wall-sized mural, strip by strip and color by color. As an ingenious collaboration between digital imagery and robotics, the giant plotter is unique. But the special talents of computer graphics are increasingly used in another area of the visual arts, animation. To an art form that was once the near-exclusive province of film, computers offer a much faster method of animating images. Again, through a digitizing tablet, an artist can create a figure by drawing in just enough points to determine its size and rough shape. For a symmetrical object, all the computer needs is the outline of one side, which is then shaped into a fluid form, regenerated, and filled in with color and three-dimensional detail. The software calculates and reproduces the characteristics of light and shadow that the object would possess in 3D. Finally, to animate the drawing, the artist specifies some key camera positions from which the object is viewed in space. The program then fills in the missing frames that simulate movement between those points. Making a drawing come to life is the most tedious part of an animator's job. Fortunately, it is also readily adaptable to digital processing. The systems used to produce these images are not designed to replace artists, but to assist them. And with enough human talent, they can mimic reality in detail or expand it to the fringes of our imagination. Our guests around the table now are Michael Arendt. Michael's a computer artist and design director with Aaron Marcus & Associates in Berkeley. And next to Michael is Don McKinney, vice president with Silicon Graphics here in Mountain View in the Silicon Valley. Herb?
Michael, in your consultant role, you use all kinds of computers graphics equipment. You have a setup here today for us. Do you want to tell us a little bit about this equipment and what you're going to do?
Well, this is an 8-bit microcomputer, which is very similar to the type of computers that most of the viewers would use in their home, for instance, to play games. And we use these type of systems, for instance, to create imagery for digital directories and education software and such like that.
And what exactly do you show us how you use this system here?
Okay, well, the traditional artist tool is a brush. This is an electronic artist tool, and it's using a graphics tablet, which you see here, and an electronic pen. And with this, I can paint images and put graphics, combine graphics, photographic images, and text on the screen. I can very quickly load in an image here, for instance, to show you a raw photographic image that was input using a video digitizer, which is simply a video camera. And once I get the image into the computer...
That's an unfortunate example, by the way, Michael, but we'll go with it.
Once I get the image into the computer, then I can use this graphics tablet to take away parts of the image that I don't want. As you can see here, it's loading in this microcomputer.
What do you mean by parts of the images you don't want, Michael?
Well, for instance, maybe I want to take out a background and put in another background, or I want to take out areas where I would like to put in other types of things like text and things like that, which I'll demonstrate here. I'll show you, for instance, I'm showing you the build of an image.
Don, while Michael is working here a second, there are great memory demands, aren't there, in doing graphics? How do you accomplish that with just a small microcomputer?
Well, and really it depends on the exact amount of memory. The memory requirements really are the requirements of the amount of color that you have, and also what we call the resolution of the screen. So the higher and smoother the image appears, the more memory is required. In the case of what you'll see later today, we have approximately 3 million bytes of memory just used to store an image in real time.
Okay, Michael, I'm sorry, you're ready.
Okay, now I've taken away the background, and now I've put in a cartoon bubble here, and then I can load in another image here to show you other things that I've...
So you're loading images you've pre-prepared?
Yes, I pre-prepared these images.
How did you go about getting the old background out? Did you trace around it or something?
Yes, you can block it out with a function on the tablet using a black background blockout. And then, so as you can see, the image is slowly building here, and then I'll show you the final image that I've created, and then I can show you how you can manipulate that image other ways also.
What is the tablet you're using? Tell me how that works.
Well, it works by addressing various areas in the computer memory, and essentially it's giving it a command either to put color onto the screen or putting geometric figures on the screen like circles or grids. And you can also put text on the screen, as you see here. Here's the final image I've built, which has a combination of a photographic image. It has graphics in the background, and it has text also combined with those graphics. And I've been able to do that with this tablet. I can also, for instance, do things like turn the image upside down, or I can also flip-flop the image this way here, and then I could bring it back up. I can also invert the colors, for instance, so I can make it negative or make them in new colors. And then there are other functions on the tablet, too, that you can do. For instance, you can create textures with what's called electronic brushes and things like that.
Okay, well, we're moving our way up from the simple koala pad to something more sophisticated. And, Don, that gets us into your area. And I think you have your iris system set up over in the other part of the studio here. So let's take a walk over and see what iris does.